I am pleased to have here today Simona Stoyanova and virtually as well Gabriel Bodard from the Institute of Classical Studies of the University of London. Today we are dealing with a topic that interests me personally as well as a librarian and historian. It is about cataloging open access classic serials. Simona, let me say some words about Simona. Simona Stoyanova, she made a BA in classical philology in Sofia University in Bulgaria, and then pursued an MA in classics and digital humanities at King's College in 2011 or 12. Not sure about this, but
from 11 to 12.
Yes. And everyone who is working in the field of epigraphy is well known to or knows her name because she's a co-author of the Epidoc guidelines for XML, which are mainly used if you work on epigraphics. And as well in King's College, she already worked on 2 digital epigraphy projects: the inscriptions of the Roman Cyrenaica and the ancient inscriptions of the northern Black Sea. Then in 2013 a break came because she moved to Leipzig to work at the Humboldt Chair of Digital Humanities, namely Gregory Crane, as a research associate on the Open Greek and Latin project. Then in 2016 she came back to London and worked again with the ancient inscription of the northern Black Sea, and as well doing this project, which she shows us now. Besides of her scientific interest, she is as well a teacher at university with workshops on digital scholarly editing and textual criticism, and as well on the digital encoding of papyrology and epigraphy. So she's a specialist in TEI XML and as well in Epidoc. I'm very interested in hearing her talk, and I hope we have a nice discussion. As always, we are filming the presentation and as well the discussion. And after the discussion is ended, we can invite you, at least 6 people, because we don't have enough glasses, for some wine and some salty stuff. Thank you, Simona.
Thank you very much. Is it okay if I stand for the camera? Is it fine? Okay. Because I like to flail about. So first of all, thank you very much for inviting me to speak today to you. This is really exciting. I've been involved with the London flavour of the Digital Classicist seminar for a while, so it's really a treat to be invited to speak to you today. First of all, how many librarians in the room? Okay, good. So I should say that I'm not a trained librarian. As you just heard, I'm a classicist with some digital humanities training. And that also means I'm not a hardcore programmer either. So this project this year has been very challenging, very interesting for me, because I delved into the world of library and information science, trying to do both library stuff and programming stuff. So, a quick overview of what we're going to talk about today. I'm going to present the aim of the so-called COAX project, then the sources that we started working with, the process and methodology. Then we're going to delve into the nitty-gritty of what actually happened. And we're going to see some code as well. I hope it looks fine on the screen. And we're going to finish with the current results and outlook to the future. So we know that in classics, not only, but that's my field. So in classics, a big number of journals are all stored in JSTOR, right? And if you're enrolled at a university or at a research library, you have access to those classics journals because your university or your library or both pay for them. It's all subscription-based, right? And that's great that we have them, but that means they're not really open, right? Because you need to be a member of a certain kind of institution to have access to those journals. Now, a number of journals, a good number of them, I've done the math, and it's about the same amount, really, of journals concerning classics and ancient history are actually open access, partially or completely. But they're frequently, maybe not completely always, but frequently excluded from the traditional library catalogues of the big university or research libraries, for whatever reason. Maybe, you know, they're somewhere open on the web, so why do we need to put them in our catalogues or something? The rationale is not completely clear to me yet. But what I found is that the amount is really sort of comparable of the open stuff and the non-open stuff. And if you're a student looking in your local university library for stuff, you're going to find only the subscription-based ones in your catalogue, more often than not. Not always, but more often than not. So what do we do with the open publications that are there? Do we just let them be hidden? Or do we actually put them on the same level in our catalogues as the subscription-based, so our students can find both and then decide which ones to pick and what to do? So that was one of the reasons for this project to exist, to see, okay, what are the numbers? Is it reasonable to include the open access journals into a library catalogue, namely the catalogue of the Institute of Classical Studies, to provide the same access for our students as they already have to the JSTOR material. Now, apart from all that, we found that the Ancient World Online blog, which is a blog hosted at the University of New York University, has already compiled a list of these open access classics journals. So that's quite neat because, you know, most of them, there's a good chance most of them will be there. So we start from that batch of records. And we found that they cover not only classics, but ancient history, and not only Greek and Roman classics, but classics in terms of Mediterranean at large, which is quite handy because it gives us more material, right? Which is also called classics in other traditions, which we may not call the same way. Also, the stuff in JSTOR is predominantly English. Some German, some French, but mainly English. What about all the rest of the stuff, right? A big portion of the open journals are not in English, which is great, right? So that's another advantage, to involve other languages and other research communities into what we can give to our students, because our students come from all over the place too. So they lose something if we don't provide everything we can, right? The third thing that I wanted to mention is the bit that's written at the very end. So even the so-called open JSTOR, which kind of recently emerged, it's still not completely open. So you can see the PDF, you can download it, you can read it. You can't do anything with it programmatically. You can't text mine it. You can't do any kind of processing on the text. However, on the open stuff, you can. So that's another added advantage for further research. For example, the citation extraction that Matteo Romanello, who used to work here until recently, was doing, or name identity recognition, any kind of text mining activity you can't do on the JSTOR stuff, you can on most of the open stuff. So the idea was to take the open stuff, bring it into the catalog with the subscription-based stuff. So these are the institutions involved. As you can see, the DAI is under there as well, because we've had conversations with a few people there about process, methodology, all that sort of thing, and tomorrow I have another meeting with them. So these are the institutions whose expertise I've used in trying to do what I'm going to show you now. Okay, so we talked briefly about the Ancient World Open Online Index. So the number is about, let's say, 1,500 periodicals. The first thing that needed to be done is to have a look at them and to see how many of them actually have reasonable amount of bibliographic information that can be useful to a library, because only a URL and a volume number isn't that useful. So some kind of survey of that needed to be done. As you can imagine, data that's been scraped from the web, I'm going to give a small example of that a bit later on, is fundamentally messy. And it's very uneven. So some records are very detailed. Clearly, they've been curated by somebody. Other records, they only have a couple of things. A librarian would look at them and say, I can't work with that. I need to add all of it on my own. What's the point in scraping it in the first place? So there was, and there still is indeed, some amount of manual curation of all of those records. So just to say that, you know, Python can't fix everything, even Python, right? So just a word of caution. That you still need to know your data to actually do stuff with it, because it's always going to be messy on some level. So once we had surveyed the Ancient World Online index, then we had to figure out what to do with the actual files, because the index files are in JSON format. I'm going to explain what that is, so don't worry about it. You're going to know all about it by the end of tonight. So AWOL has a JSON dump of files, but the Institute of Classical Studies library catalog works with MARC format files. Again, something you're going to see and be slightly horrified by in a minute. So we had to transform the stuff from one format to another, which sounds, you know, easy. Not so easy, actually. There's an XML serialization of MARC, which makes things slightly more kind of nice to an XML person like myself. And also the Library of Congress has a number of transformation style sheets to make the process, I won't use the word seamless because it never is, but to make the process slightly less painful, let's say. So all of these formats had to be kind of thought about to see what was the reasonable way of going from one to the other. So once the AWOL stuff was, we were familiar with it, and we've been concentrating on it, I have to say. So the stuff that you see on the top right is something to do in the future, because there will be a lot of duplication between the stuff in AWOL and the stuff in one of these other digital libraries. So one thing that is important to do is compare and decide whose records are the better ones and get them rather than the other ones, etc. But that's just to say that it's not only the Ancient World Online index. There's more digital libraries out there that need to be scraped and surveyed properly to do this on a large scale, because this was a one-year project, I should have said. So there's only so much we can accomplish in a year. And the final sort of result of all of this is a bundle of new records to be added to the library, the code that did the whole thing, a user guide for librarians, not for well, both, I guess, but the programmers can look at the comments in the code and figure out what's happening, though that's something to keep in mind, documentation. But a user guide primarily for librarians to know what to do with that code, and a trial ingest, which is in progress right now. So, what's the progress from beginning to end? We have some data floating somewhere on the web, in our case, in the Ancient World Online index. Then we get it from there with Python, yay. Then we transform the data that's in various formats, potentially, into one format, our library format. We do that with Python, maybe some help from the Library of Congress XSLT. And then we ingest the data into our catalog. with something depending on what your catalog system looks like and what kind of transfer protocol it's using. So it says here to be continued because I'm going to go deep into this process, but before I do, I just want to sort of conclude the main overview and then we go into the actual transformation bit. So the outcomes are as I said, about 1,500 new entries into the ICS catalog, the bundle of records, both in MARC file, because MARC is a very old and difficult, let's put it that way, format to work with, but many libraries still use it. So it's good to have the stuff, because most people nowadays, I mean nowadays the last 10 years, have been trying to sort of move away from MARC and transform MARC into other things, more transferable things. But I've been trying to do the other way around, to transform HTML, JSON, all sorts of things into MARC, simply because our library uses MARC. And that's true for many libraries. Nobody likes it, everybody has to do it for the time being. So the records will be in MARC, in the XML serialization of MARC, and I guess it would be useful to have them in JSON as well, but they're already in JSON, so that's kind of pointless. And the point of this bundle of metadata is to be used by other libraries to ingest in their own catalogs if they wanted to. All the code will be published on GitHub and how-to guide, how to do the thing. And so we're coming to sort of towards the end of that because I have a few more weeks on the job. So sort of wrapping all of that up. And then in the future, potentially, what we would like to do is to extend this kind of work to other institutes at the School of Advanced Study at the University of London to work on historical data, etc., depending on the legal data in the legal institute and all of that sort of thing, because obviously they would have their own sort of specific requirements for their disciplines. To work with other open repositories as well, not just the Ancient World Online one, and to include potentially interested international parties. So that's kind of the whole overview of the project. Now, why Python? So I don't know how many of you are familiar with Python. So I'm not going to go into the details here, but just to say that it's a programming language. It's been around for a while. It's used basically everywhere for all sorts of things. And it's not named after the snake. It's named after Monty Python. I thought that was particularly important to point out. So just a sort of to make sure that when I say Python, people understand what's going on. OK, so being not a programmer, I kind of have to say now that I am, but I had to sort of learn to approach my data and my problems in a different way. And that's a very old joke, but it's appropriate in here. So the mom says, please go to the shop and buy 1 bottle of milk. If they have eggs, buy 6. And the person comes back with 6 bottles of milk. And the mom says, so why did you buy 6 bottles of milk? Well, because they had eggs. Right, so what you say and what you mean and what you understand and what a binary thing understands are completely different things. So just a word of caution that as a humanities person going into this programmatic problem, I often reminded myself to count the bottles of milk and the eggs in my code. And the other thing that I'd like to, I like to say when talking about this project is, again, a famous quotation from Charles Babbage when he said, somebody asked him, if you put the wrong figures into the machine, will the right answers come out? And he, completely unable to comprehend that question. Because clearly what you put into it, your code can transform in some way. It can't correct it for you if it was wrong at the beginning. So again, we go back to the thing that you need to know your data very well to be able to do anything reasonable with it. So, as I mentioned, the stuff on the web is messy, structurally speaking, as files. And there are all sorts of things you could need or want to download or scrape from an online catalog or some kind of scholarly database. It could be text, images, links, it could be anything. And there's different ways and approaches to do that. So once you've sort of done this, actually what's the process? What do you do? So you can open a URL from your program, not typing it in your browser, but tell your program, go there and open this. And once the page is accessible to you, then you can extract some information from it. You can figure out what's the structure. And you can also create new files like that. So some of the things that I had to work with were in HTML. Some of them were in XML. Again, because I assume that's a very sort of varied group of people. Just a very quick sort of note as to these words that I'm using all the time. So HTML is what the web is written in, basically. It's a structured format. We're going to have a look at an example in a minute. XML is a markup language, so you don't just write a web page on it, but you encode documents in it. They both use sort of angle bracket things, and they're used extensively on the web, and XML is the base of all sorts of standards for publishing, for aircraft manuals, for all sorts of things. So this is what HTML basically looks like. Something at the top to tell us this document is an HTML document. You see the structure, the nested things, one inside the other, and some content in the middle. And the basic XML structure, I've chosen a TEI document. Doesn't really matter what one, but I like the TEI, so there you go. Again, at the beginning, you have the declaration telling you this is an XML document. Then you have a very hierarchical, well-structured, quite human-readable document to tell you what's going on. You know, there's a header, there's a facsimile, so you expect an image of some description there. Then you have the text with various divisions. So, when a text is structured, that makes it potentially easier for us to parse it, so to look through it and extract relevant bits. That's not always true. So if the document was written untidily, that could make your life easier, a nightmare, I mean. If the document was very well structured, but too complex, so there's too much encoding, too many tags, that can be a bit difficult to extract things from it. So there's always a balance between some stuff randomly written, which if it's not well structured, you can't really query it properly, or some other stuff very dense, and then that density of elements is kind of, again, difficult to process. So, however, let's assume that a structured document is generally a good thing, and that is true. That structure helps you figure out which are the relevant bits for your needs. So for my HTML pages of online journals, I'm not going to use the whole web page, right? I don't care about the title of the page or the design at the footer telling me who designed the web page or something like that. I need to know the bibliographic stuff, right? So I'm going to pick only those sections that include my bibliographic information. That's what we mean by parsing structured text in our library context. So, yeah, somebody likes it. So Python, the way Python works, as you're going to see in a minute, is that there is a basic kind of bundle of code that you can use just, you know, you sit on your laptop, you install it, you use it. there are certain things specific, we call them libraries, which are specific bundles of code to do a particular task, which not everybody would want to or need to do. And these libraries you need to install before you can use them. You don't particularly need to worry about that. I was going to say that Beautiful Soup is one such library that doesn't come in the generic Python bundle, but you install it separately. And it helps you navigate the structure of an HTML or an XML document, which is why it's in our presentation. So, some code to delight and entertain you. I hope you can see it from there. I can't really make it bigger, I'm sorry. So just a brief, very simple example of extracting some stuff, in our case, links, from the page of an online journal. So we have a journal, we have some paragraph describing the journal, then we have a list of links to each issue of the journal. Now we don't need all the other information on the page, RSS feed and Twitter handle and all of that, we don't care about that. So we only want to get the links to the individual issues of that journal. So just quickly, here in the bit import blah 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 blah, this is where we install the library, so the extra bundles that we need to process our stuff. And then we just say, I have an HTML document, open it, this is the URL. Then with Beautiful Soup, we tell it to parse it with a certain parser. You don't need to particularly understand this, I just want you to, to see what's happening without worrying about every single detail, right? Does that make sense? Okay, so we tell it, open it with, process it with Beautiful Soup with this particular parser, read it, and then for every link, display it as an HTML link. So discard everything else, only get me the links in this page. And we end up with a list like this. Now that's very simple and can be problematic because in this web page we could have other links that have nothing to do with the issues of this journal. We could have links back to the institution that publishes it, links to authors, links to other libraries, to all sorts of things. So we need to go back to our code, specify which links we need to actually take. So that's just a sort of a taster of how we scrape anything at all. But then once you actually see your result, you think, oh, I've got a few things that I don't need, so I'll go get rid of them, but how, etc. Does that make sense to people? Okay. So why do we care about this and libraries together? So I said some words at the beginning like JSON and MARC and things. And the things on the left are the main data formats that I work with, and I'm going to explain what they look like and what we use them for. And the stuff on the right is how I do stuff with them. Right. One is the Python code that I'm writing. The other is Library of Congress transformation style sheets, because you should never invent the wheel all over again. Right? If it's there, use it. So what's JSON? It's a very popular Exchange format because it's very, well, short. It's not XML, it's not processed in a difficult kind of cumbersome way. This is sort of what it looks like. And you have something that defines something else. These things are called a key and a value. And as you'll see in Python, it's very easy to work with it because this resembles a Python dictionary in structure. So there's already a mechanism to deal with JSON more or less painlessly in Python. But this is just to show you what it looks like. And this, again, I'm sorry it's small. I can attempt to make it bigger, but probably break something. Okay. again, you don't need to read every single line of this. That's just to show you that this is the JSON file of a journal, and you can see that we have domain, Harvard is part of which full title, the URL is this one, the resource date, it was last accessed on this date, etc., etc. So this is, you know, that makes sense as a library metadata file, right? You can sort of, you know, you can read it as a human, but it's also quite sort of neat and understandable for a machine as well. So this is the kind of JSON files that I have. I need to transform into Mark. Now Mark, my favorite. So this is what Mark looks like. It's binary. So yeah, it's a lot of fun. So you can't just open it in a text editor. You need a specific application to read it. Or you have to read it in Python, but to read it in Python, you need to install a Python library that works with Mark. So it's convoluted. So if you're a librarian and you have your nice library content management system, it's all fine because you can see your files, you can edit them, and it's all grand. If you're a programmer trying to extract anything from them, it's a nightmare because you need to figure out how to actually open the thing. To even just see it and then figure out what to do. So what this thing does, I mean, that was perfectly understandable for librarians, not for the rest of us. What this means is, so these sort of fields here have codes, numeric codes, because it's more fun, but they also have sub thingies which are letters. Right? This $A thing depends on this 35 thing. And if there was a $B thing, it would mean something else than this $A thing. It's great fun. So you can kind of figure out that code number 100, $A, is the name of the author. And for some reason, 100 code points later, you get to the title. And so on and so forth. You know, dates, library codes. That was fun to crack, but honestly, it was that was a headache. So that's what it looks like, and that's what our library uses, as well as many other libraries who, you know, because there's nothing really sensible enough and workable enough yet to substitute it. So people work with it. But so the thing is that I said that it's binary. That means it's very sort of fast processing. So if you have, you know, millions and millions of entry files like this, that's fine. If you've got millions and millions of XML files, that's a bit harder. Now maybe with, you know, cluster computing and fancy words like that and sort of more power in processing, it wouldn't be such a problem anymore. And maybe we could work primarily with XML. I can't really say, because it depends on the library, on the size of the library, on the size of the computer that the library has, etc. But this is what Mark means. Now this is the XML version of Mark, which was designed, again, by the Library of Congress to sort of help people out, people like me who did not have the Mark codes internalized. And this is kind of terrible as well, because it is XML, right? So structurally, it makes sense to us. But if you actually look at it, it doesn't tell me anything as a human, right? It tells me this is the data field that has a tag 100, and has an indicator 1 and a second indicator 0. So again, I need to know the mark to understand what the hell is going on here. Right? So we have the 100 with the A and the D, and we have the 100 again. So yeah, it is XML, but it's not particularly helpful, I don't think. Apologies, Library of Congress. Okay, so mods is another standard. The librarians like their standards. But they have all sorts of really sort of complicated data, so I understand. So mods is a markup for what they call selected metadata from an existing MARC record. And this I like because I can read it and understand it. So it is XML again, which you've already sort of know that I do like generally in my life. But this is stuff that I can read, so it says title, right? It doesn't say code 100, go through the documentation, have a cup of tea. It says title, which is amazing. It says name and place and publisher and stuff like that. So this is, I like this quite a lot. Again, I've realized that for processing, that's a pain because of the size of an XML file. But I can open it in anything, and the structure really helps me understand what's happening. So, okay, so I mentioned the Library of Congress style sheets. This slide is just to give you a taste of what they actually do. So they match, so this template match thing, they match something from one of these crazy formats and then tell it to transform magically, keep the content, but stick it into a tag that says title. That's what they do. That's how the transformation works. However, they don't work with JSON, which is the majority of the data files that I do have. So that's why I had to learn to use Python. So, okay. So on the right, you see a snippet of JSON from the Ancient World Online index. And you can see that there is some content over there, but the rest of the stuff is just empty square brackets, or it says null. So, you know, there's nothing there. There's no valuable information that we can extract. So when we extract information, we first pick what actually we want to extract from the whole thing, because we very rarely want the actual whole thing. There may be empty fields, like here. There may be duplicate information for whatever reason. There may be local use identifiers, which some other library uses that we got the record from, but ours don't, so we don't need it. So everything that's superfluous or empty, we get rid of. Again, a snippet of Python. So we load our file. It's a JSON file, you can see. And then we've written a function that basically removes all of the empty bits. All of this thing goes through all of these things and says, okay, if extent is null, if anything is null or empty, just don't output it in the new file. Get rid of it, because we don't need it. And then we print it to see what's happened. And this is what's happened. So from that long, long file, that it goes down and down and down. I couldn't fit the whole thing on the screen. From that long file, we end up with a list of, what, 5 things which have content. And these are the 5 things. The domain, URL, title, etc. These are the 5 things that we want to keep from this long record. Because the rest is no good. So, just a reminder, this is Mark. This is what it looks like. Is anybody here called Mark? Hope not. Well, you have a suffix, it's not the same. So this is what it looks like with the codes and subfields and indicators and everything. And this is what JSON looks like with the keys and values and equal sign in between them. So just a reminder, because we're going to transform from one to the other now. So first, what I had to do, it was obviously to map the MARC fields to the JSON keys that we have in our JSON dump. So that was fun. I mean, really, it was fun. I didn't say that ironically. But sometimes it was difficult as well, because again, the MARC documentation is so massive. And I couldn't cope with it on my own, so I did the sensible thing and talked to an actual trained librarian, right? That's what you do when you get in trouble. You talk to your librarian. And they're very nice and explained everything. It's very complicated. But just a few things I selected for tonight is that, you know, field number 856, subfield A, apparently maps to what we call domain in our JSON files and all of that. So that was the, once I actually had the JSON more or less cleaned, the next step was to map the stuff from JSON from the stuff to Mark to then be able to transfer the content from one to the other. That makes sense so far? Okay. The stuff with the, after the hash thingamies are what we call comments, which is essential. So I try to be good and document my code inside my code with these comments, which are not processed. They're only notes to myself, or to, like, you know, ideally other people as well. Because I've looked at all sorts of codes while sort of learning how to do this, and not everybody does document things, either in a separate document or inside the code. So you're lost more often than not trying to reverse engineer somebody's thought and to figure out, what are you doing here? So I've tried to be good and document my stuff inside as well. So this is what happens in the end. So we create a new record, and then we're saying if my file has a key domain, then add a field with this number and these indicators, and keep the content that domain from the JSON has, right? And so on for all of the fields that exist. And then once you've extracted the stuff and mapped it to the Mark stuff that corresponds to it, you then write a new Mark file. So you keep that content in the way that you've extracted it and mapped it, and then you output it into Mark. And then, ideally, as I do, I mean, I open everything before I say it's finished to have a look at it. So the stuff at the end basically just means grab this file and read it. Show me on the screen what's happening so I can check that everything makes sense before I further process it. So that was an example with one file, right? You can see the name of the file over there. It's just the one. What do we do with the bundle of things that we want to output in another bundle of things? So, same thing, only we need to say, don't open this one file, but open me a directory, which I've called cleverly input, and then open every single JSON file in it. For this example, there are only 3, because I couldn't fit more on the screen, and it doesn't really make a difference. But basically, grab everything that's a JSON file from this folder and do things to it, right? And then you can kind of see from my comments what's happening here. I want to time the process. Not for me. I don't particularly really mind. My computer can cope with it for the moment. But for the libraries, because I need to be able to give people estimates. So for 1,000 files, that's the amount of time it takes. For 5,000 files, etc. Because that's important, because you never know what kind of machine that the library that wants your stuff could have. Whoops. Then create a Mark record. Again, you already saw that. That's the mapping of things. Create these fields and grab the stuff from the JSON keys. Then keep the file name rather than renaming things. I mean, this is not really a sensible file name, but I'm keeping them for the moment. And then output the file into a different directory, now called output, etc. And this is what I get. It tells me that it's processing these files, it gives me times, etc., which is, as I said, it's useful when you're dealing with lots and lots of data. With 3 files, I don't really care, right? With with 1,500, somebody would. Okay, and a sanity check while I'm working all the time, because I'm slightly paranoid, maybe because I'm not, a real programmer, as I say. I just go into this output folder, and display everything that's marked one by one. And this is what I get. I get the file name, and then I get the pretty mark records with their codes and subfields and things. That's the end result of this process on multiple files. Does that make sense to people? So, okay, that was a kind of an ideal case. Things are always a bit messier in real life. But once this process is done and the stuff is in MARC, it goes to the library catalog. Now, how you ingest it more or less depends on your library catalog. I mean, I can give suggestions and stuff like that, but as long as you have the files, which will be in the GitHub repository when I'm done, then you decide what's the best way for you to ingest them into your library catalog. Now, we wanted to do something cool, but I don't think I'll have the time or the skill to do it. And that was to allow people to pick and choose which catalogs to ingest from our data dump. I'm not sure that's possible in the time that I have left. But it will be kind of cool to develop in the future. And another thing is to do some kind of an automated update. So when there's a new article uploaded to a journal that we already have the record of, how to automatically get that new article rather than go through the whole process and then get rid of duplicates and all of that. That's slightly baffling to me for the moment. So any clever suggestions would be very welcome indeed. And I think that's it. Thank you very much.